Hi, I'm Joe Berkovitz, co-chair of the Music Notation Community Group for the W3C and president of Noteflight. And I want to demonstrate to you the concept of programming with music notation using a document object model, or DOM. DOM is a data structure. It's a tree of nodes, and each node represents a node in a document, quite commonly an XML document or HTML document. In this case, we'll be using a DOM that represents a music XML document. And we'll look at how that makes it really, really easy to build simple interactive applications based on music notation. And these could, of course, also be quite complex ones, but this one's super simple. It's just a simple music theory exercise where you have some randomly generated triads, and the user is asked to click on the root of each triad, and as they click on notes, there's a tally of right and wrong notes. So here I'm clicking on an E in a C major triad, that's wrong, and my wrong count went up. I'm going to click on the C, and that's right, my right count went up. Let's try this next one over here. I'll get this one wrong on purpose again, and then right. And how about this? Looks like D minor. Yay, I'm doing great. But the point isn't to show how strong I am at identifying roots. I'm trying to show how we could build simple applications like this without doing a lot of programming using the document object model. So let's take a look at how this application was actually built. And I think what's striking about this technique is you can do things like what we're looking at while knowing very, very little to nothing about the engine or the code that's actually showing the notation and handling user interaction with the notation. Instead, all the code is focused on manipulating an encoding of music notation, and in this case we're using Music XML as a straightforward industry standard for representing notation. So I'm going to take a look at our code and just look a little bit at how we did that. This is the entire source code for the app. It's not too long. We've got a section that just contains some styling for the user interface, like fonts and colors for the little UI at the top. We're loading some JavaScript up here. So, but this is where the meat of the application is. Here is some HTML that corresponds to the same stuff we see at the top, the button that generates the new bunch of triads and the counters. So that's the HTML piece. The interesting part is, of course, the JavaScript, the programming. So we have a short section here that loads a music XML file into memory as a DOM, and this is the only part of the code that actually talks to some Noteflight code to tell it, hey, here's the DOM that I want you to show within the page. And that music notation will be displayed in this div element up here. But once that's done, there's no more talking to Noteflight. All the rest of the programming is done using this DOM, which we're storing in a variable called exercise. And here we're going to be using the jQuery library to manipulate that DOM. We could be calling the actual lower level DOM API to add change attributes, add elements, and so forth. But I think it's kind of cool to use jQuery because so many web programmers use it, and this is not some customized version of jQuery, it's the regular one. So here's the bit that generates the new randomized triads. I'm not going to go through all the logic of it. I'm just going to point out that what it does with respect to the DOM. So the first thing it does is it goes into the exercise DOM, it finds the first measure, and it clears it. So that removes all the stuff that's in the DOM. All the notes are gone at that point. And then there's a couple of nested loops that generate music XML note elements, which are tagged as chords if they're not the first note in the chord. And the pitches of the triad are added. All this just using jQuery and XML, no talking to Noteflight. the notes are stuck into the measure by just appending them as new XML elements. And as all these operations are taking place on the DOM, the notes actually are shown by the viewer because it's monitoring the DOM to see what's being done to it, and it tracks changes to the DOM. And then the cool part, the interactivity, we have two event listeners depending on whether the note that was generated and just added to the DOM is a root or not. If it's a root, we add a little listener function that says change the color attribute of this, which is the DOM object receiving the event, to this color, and update some counters and show them that's just HTML stuff. If it's a non-root note, non-root tone, then we're going to change it to red because that's not the intended note that the user wanted to click. So again, here we go over here. We've got our triads. I'll click this note, that's right. Click this note, it's wrong. Those are the consequences of these changes that we see here to the DOM, causing the note to change color. Now, we could literally be making any change we want to this DOM at all. So for instance, and let's actually look at the DOM in the Google Chrome debugger. You can sort of see it in here. Here's a music XML document. It's a nice little debugger, lets us kind of view what's in here, a part, and it's got a measure, and the measure's got some notes, and the notes have some stuff. Let's change some things in this DOM. So, what we might do something kind of, let's see, let's change the title of it. So I'm looking at the exercise. Let's blow this up a little bit. It's kind of small. We're going to take the exercise DOM, change the work title to something new, and look, it changes. We haven't talked to Noteflight and told it changed the title. We talked to the document and changed its title as Music XML. Let's do something kind of more sophisticated here. We're going to find, using jQuery, find all the pitches that contain C, and we're going to append an accidental element to all those notes. And there are the sharps showing up. So DOM-based programming, you basically just manipulate a document and let some other component of the software that you don't have to worry about track your changes and dispatch event notifications when the user interacts with that document. And although this is a very simple example, the renderer could be showing a document of any desired complexity. You can imagine loading up a Sonata in here and having DOM-based code that looks through the Sonata, identifies triads, and sets the same assignment to the student using the same technique. So that is my little example. A couple of footnotes. I chose Music XML for this example because of its wide adoption. We could use any desired encoding. And there's nothing particularly web-based about this because DOM API bindings exist in many different languages, and there are many libraries supporting those DOM bindings. So it's a platform-independent technique for building document-based apps. And this is pertinent to the work of defining a next-generation encoding standard for music because the design of a schema for encoding music notation I think should be optimized to make this type of program quite simple. And present day Music XML is not actually, does not fulfill that criterion. So for instance, there's the extra work of identifying chord tones. And in fact, there is no container element that contains that maps onto the concept of chord. So if we want to say, change the color of a chord, that would be difficult. So these are some of the challenges ahead in making notation and coding fit well with the DOM programming paradigm. But I think it would be a problem that would be very worthwhile to solve. Thanks very much.